I will try without microphone. Do you hear me well on the back rows? Okay, then. Hi, my name is Ilja. I work as software engineer in Swedbank. And I'm working in mobile team. We are doing mobile applications for iOS and Android. When we a part of the main model, the main entity here is user. User have many accounts. Each account have transactions and balances. So each account must have many balances to support functionality to hold multiple currencies on each account. Also, user have cards, and each card is have connection to an account. We need to know from which account to take money when you pay with card. And application will have several screens. One screen is overview. Here we want to display meta information about account, the IBAN number, the name that you can specify for your account. And also we want to show here available balance and the amount of money reserved. And of course list of transactions. So to show all information needed on this screen, we need to call 3 different services. We need to load list of accounts with the metadata, and only after this request is finished, only then when we have account ID, we can load balances and transactions. So this problem means that sequential request must be made. Those can be done in parallel, and we need to wait, and the loading time for user will be increased twice bigger. So another screen in application is a card view. Here we will show the name of card, the card number, and again information about balance to which card is connected, the available balance, and credit limit. Credit limit will be shown only for credit cards. So again, 2 services needed, list of card and balances. The balance service could be the same like in previous screen, but there is small difference. We can't just take and reuse this service from first screen, because it will return only available balance and amount of money reserved. But here on the second screen also credit limit needed. This credit limit is connected to balance, and it means that if we add all fields, then some fields will be not needed on different screens. So the data that will be sent to the client will be excessive. In this example, difference is only in one screen, in one field, but in more complicated scenarios, more complex data, this difference could be bigger. So the actual reason of those problems are how we can fix them. we may create custom endpoints for each screen. But if we do that, then we will have another set of problems. We will couple our API and user interface tightly. This means that every time we want to change something in user interface, we will need to change API also. And versioning problem. Versioning problem is a not trivial task by itself when you deal with mobile applications, because once application is released, it will stay there forever. It is not possible to force or to push users to update to newer version. Always will be somebody who will keep old version of application for a year probably. So this versioning problem will be more complicated with custom endpoints, because we will need to continue supporting this custom endpoint for each screen, for 2 different platforms, and for several versions. But what is the actual reason of those problems? And the root cause is that backend is not adaptive. But we want to make it adaptive. We want to evolve our application rapidly, to deliver new features to customers fast, maybe make A/B testing. And if we do backend in the old way, it will be very hard to do. But what actually application need from the backend? Remember this domain model. This looks like graph, and basically what application needs is to query this graph from the backend. And we found one good technology. It's called GraphQL, or Graph Query Language. This was invented by Facebook, and they wrote the probably 100 of pages specification how this language should work, how implementation of runtime for query language should work, and what is the key parts of the language itself. Main important part of GraphQL is schema. In this schema you define the data model of your API, and the main part is type definitions. So every type that you want to expose from backend to the client must be declared in the schema. And declaration looks as follows. For example, it is balance type. We need to give a name and a set of fields that this type have. Field declaration is made as a field name, field type, and it is divided by semicolon. Exclamation mark at the big end of the type name means that this type is non-nullable. So whenever the instance of this type will be used, GraphQL runtime environment must ensure that there will be value. Otherwise, error will be thrown. So in this case, we are using simple types like a string or big decimal. In GraphQL, they called scalar types. In declaration also, we may use custom types. For example, this balance type that was declared on previously, we can use it in new types. In this case, it is array of balances. And also for in-field declaration, we can use parameters. Each parameter also will have type, and it shouldn't be a scalar type. You can use custom type here also. Here these types is parameters used for pagination, but you may use parameters to pass IDs if you need to load some exact record. When all types are declared, we need to define root query and root mutation types. These types looks like any regular scalar custom type in GraphQL. Only different is that when these types are declared, we need to put them as an entry point into our schema, like a query and mutation. The main difference between query and mutation is only in semantics. So query may not have side effects, and mutation are meant to change data on the backend. And that's only difference. When schema is defined, we can write queries and pass them to GraphQL runtime. Query declaration begins from a statement that it is query or mutation, and then we need to specify fields which we want to load from backend. If this field, the type of this field is not a scalar type but a custom type, we need to define which fields from this type we want to load. Execute this query, and the response will contain only that data what was asked. We can add more fields, and again the response always is in the same shape as the request was. Again, we may want to load balances for accounts, so it is possible to write nested queries, and this will mean that we will don't need to make this sequential request to load additional data. So, how everything works? First, when the query is passed to GraphQL runtime environment, it will be validated. Runtime environment must ensure that only valid fields is used, only all types that have subfields are defined. If a field have parameters and those parameters is non-nullable, then those parameters are passed and all names are correct. When query is validated, the execution times begin. So this query that we composed, we may think it like a calling of fields like methods or functions on the types. Indeed, it is so. When you implement API, when you implement backend, each field declared in schema must be backed by a function or method, and this function is called data fetcher. In different implementations of GraphQL, the name of data fetcher may be resolver. So GraphQL will build something like a tree of resolver functions, and for each type that return value, it will call this data fetcher, and the result will be passed to child data fetcher functions. The execution will be ended when all scalar types are fetched and retrieved. And the result will be the key value pair, where key is name of field and the value is the value itself returned by data fetcher. This set of key value pairs will be passed to parent data fetcher and use it as a result, which it will be like a bottom up. Also, GraphQL have a very good feature. It's called schema introspection. It gives possibility to application to know which types and which fields is declared in the schema itself. So this schema introspection is defined in GraphQL specification, and each runtime environment, each implementation must provide a set of queries out of the box, which will make it possible to load data about the schema itself. So in this case, we get information which root queries have our schema. Those queries may be more complex. We may load not only the root queries, but types of those root queries and fields that what those queries have. Thanks to this schema introspection functionality, GraphQL have great tooling. One tool is GraphQL. It is a web-based application. You can deploy it together with your backend, and you can write query in this. It is very handy in testing and in development process also. You probably want to test the queries and the API before you commit something, so this is very handy. It provides auto-completion functionality, and each field can have documentation also in description what is the semantics about this field. So this GraphQL tool will show you or make it possible to browse this documentation. Another tool is Insomnia. It is a very handy REST client. You need to install it, and this Insomnia have out-of-the-box support for GraphQL. Let's overview problems that was...
Sorry, a bit of a side note. Other than Insomnia, there's still like a possibility to test the GraphQL API with sending a regular either GET or POST request, so that to the payload or the query itself you provide like as a request body or as a query string.
Yes, this means that GraphQL runtime environment is just an engine, and it is agnostic about database and the method how the query will be delivered from client to the GraphQL engine itself. It could be done via servlet if in Java, and then this query will be sent yes, like just a parameter or like a body. So, but I will return to overview of problems. And excessive or insufficient data, check. Application will ask only data what is needed. Application developer will write special queries for each screen, for each use case, and the amount of data what will be loaded from backend to application will be just what is needed. Sequential requests, check. We can write nested queries, and this data which have relations can be loaded with one request. This decrease load on application side, because for Android and for iOS there is recommendations that if you make a few requests as possible, it will save batteries, save the traffic, and so on. And also for backend, because if we can make these nested queries, we can do batching and make those query execution more effective. Coupling backend with UI problem, check. Backend API provide possibility for application to load any data what is needed, and there is no need to make some special endpoints or special queries for exact screen. And versioning problem, also check. If we decide that we need to add more fields, old version of application will even not know about that those fields was added. And if at some point of time we will decide to remove another field, then we can mark this field as deprecated, stop using this field in new version of applications, and just we can monitor how often this field is used, and when this amount of version of application that users still use, who don't want to update to new version, the amount of these users is small enough, we can drop support of the old version. The difference between this approach and REST approach is that in this case we will support only one field that we wanted to throw away, but in REST approach we will have to support the whole REST service and entry point for old version.
But it's not so bad if we will So right now you're telling that versioning is good, that you would just duplicate field, and then client decide what he will get or not. So in some case I will try to get some heuristic point, like it's public, and try to get everything I want to. So in real case, like as scam user, I can try to always tell you that all deprecated fields are used. So how you will do that?
But still we know in which version we stopped using this field in our application, as it is not a public API, it is our backend and our application. If you make some your own queries, then it will be illegal. But we will know that from which version we stopped to use this field, and we can just monitor usage of this version of this application.
So basically, what it means is that you have more granular tooling for deprecating your API. So like with REST, you can deprecate the entire versions, right? And with GraphQL, you can get so granular down to one single field. Barely you want to do this, but I mean the possibility is there.
It's some kind if you deprecating only one field, it's from my perspective it's harder to track than I know they have deprecated some resting point with just /version 1, 2, 3, and then I just disable it. And
yes, but for some time you will have some REST version 1, version 2, version 3, and it is 3 times bigger code on your backend that you want.
Yeah.
And do you want to support this old code?
It's not. Sometimes it's not real problem if we will not speak about biggest changes. If speak about smaller mobile application, it's cheaper to track some resting points than the new fields, and it will be more like spaghetti when you try to that version deprecates that field, that version already deprecates that field, and then it start to change structure, so on. But
no, actually on the backend you don't care about this. You basically you still expose everything, right? But then you know which version elsewhere you know which version queried what, and then you can do it decoupled from the backend.
Maybe better to see some examples.
Did I get right that you monitor every query? How you do that?
I didn't get your question.
You said that you can put some query deprecated, right?
Yes.
So you monitor every query, every available query in your API, or how, or not?
Every query is still it is loaded to the backend.
Yes,
What
and you
do you
monitor
mean?
it. The time, how many times it used?
For now we are not doing this, but it is possible. So if a field is deprecated, then data fetcher, for example, for this field can send some signal to monitoring system that deprecated field was used.
So you deprecate fields, not queries. So basically, say if the example with the account information, it has balance, it has bank account number, and it has a other field which you want to deprecate. You just mark it as a deprecate, and with newer version of your client, your mobile application, you just stop using it, and after a while you just drop it. Drop support for this field. But the endpoint stays there, the function stays there. You just don't return this field anymore. You stop making it available at some point.
But you still monitor that field.
Well, you just log it as well. You do log your request, right? Do you?
So maybe one more stuff. You tell about the front-end side, but from back-end side, how you could join your GraphQL and engine with your maybe Oracle database and back-end side. So how you
Basically, it was more about backend than UI. So when it was here, this query is executed on the backend, and then for each field, the function is provided. So GraphQL GraphQL engine will call this function that you provide for field, will give you parameters if there was there, and you wrote your code there. There could be business logic, you can connect to another microservice, you can go to database.
So it's just not filters in real cases, it's function for function.
Yeah, it's like a web interface for your actions.
Yeah. Okay.
I don't know if it is valid compare, but we can compare it with RPC maybe.
Yeah.
I like the function for function.
Yeah.
You also talked extensively about introspection.
Yes.
Can you give a few examples on how you guys use introspection, for example, to solve the problem that you had at hand, so for the app, for example? Because if I get it right, your app always knows what's in the back.
Yes.
So how do you guys use introspection?
My usage of introspection ends on those tools that I showed because I dealing with backend development, but I know that guys on mobile application, they have I don't know, very big query which can load all schema with all types and fields, and they do some partial code generation for some stubs and those.
But I mean, like to my opinion, the most useful area of application of such feature is just to communicate the interface between teams, so that like you have an efficient way for a backend team to tell front-end team what's available, like in the first place.
This is one, and another that application can load this schema and validate query before sending to backend. In this case, invalid queries will be not sent, so traffic and execution will be not spent on this.
But this shouldn't be deployed in the first place. Come on.
If something went wrong, again, mostly for development process.
If you use introspection to actually generate something for your user interface, isn't that defeating the purpose? Because you then again query the whole set of all fields from your backend. So
They
should only actually load the fields that they want, and they shouldn't generate automatically whole classes or whatever.
I don't know exact details, but I know exactly that they use this possibility that they load only what is needed. But about this code generation, I'm not 100% sure. I know that they use this introspection functionality on applications.
Do you use the GraphQL for public APIs? This way, by public APIs, I mean that from mobile application to API, it's requests they are under your developer's controls, but the public ones, because very GraphQL looks like very interesting for some hacker stuff.
I mean, like, do you look at VRS on the internet?
You can query so much information with a single query, tons of them, without any limitation and so on.
But this information will be only connected to you. So it is only your information. It is.
Like
So you still need to log in.
Yes, but if I, as a customer, if I ask for all my transaction from beginning of times, I mean, it's still like a hell of a heavy query, right?
will be yours information.
A question over here.
Yes, about you told that GraphQL can validate the strings or fields.
Query.
Query or fields?
Query. So
Query.
basically, knowing schema, like you build up the query, and before you send it, you can actually validate it against the schema. Like if it's even like does it make sense to send this query?
So if this validation fails, does user see the error or how it's handled?
It will be handled how developer will write it. You may hide this error, you may show some general error that something went bad, please report.
So you have to make a solution for this error, not GraphQL do it for yourself.
GraphQL will provide possibility, but it was stated before that these not valid queries, application in such state must not be released. So all those checks are more for development process. Because if you have a complex query, GraphQL runtime will tell you exactly where was this mistake. For example, if in this query somewhere here available balance will be misspelled with one letter, GraphQL will return the string number and the column where this error was, and exact name, field name, and yes.
And this is another extra reason not to expose it publicly, because you don't want to actually third parties know like where exactly in your code base this happened.
Cool.
Any more questions? So a question from me. So who thinks GraphQL is worthy technology to try out at least? Cool. Yeah.
Cool.
You made your point.
At the beginning there was that more about 80% even doesn't know about GraphQL, but now you want to try it. I'm happy.
Yeah. Who already uses GraphQL in production? Right now. Okay, we do. Yeah, not publicly. But anyways, Ilya, thank you so much.